In order to show that the Markov chain is statistically determined by second-order probability methods, first we need to calculate the joint probability function of P x1 equals to x1, x2 equals to x2, and xn equals to xn. And first, we use the Bayes, and we can rewrite this probability into this format. And it is equals to P xn equals to xn, given that xn minus 1 equals to xn minus 1 and xn minus 2 equals to xn minus 2, and until x1 equals to x1. And then multiply the probability of P xn minus 1 equals to xn minus 1, xn minus 2 equals to xn minus 2, and until x1 equals to x1. And because it is a Markov chain, and the nature of the Markov process is that the probability of the future is only related to the current state and not the past state. So we can rewrite this part into this format. It equals to P xn equals to xn, given that xn minus 1 equals to xn minus 1, and then multiply the probability of the joint probability function. Xn minus 2 equals to xn minus 2, and until x1 equals to x1. And then we can, using the same method, to rewrite this part, and using the same method above to rewrite this part. And finally, we can rewrite the joint probability distribution function into this format: P xn equals to xn minus 1 equals to xn minus 1, and multiple P xn minus 1 equals to xn minus 1, given that xn minus 2 equals to xn minus 2, and then multiple until P x2 equals to x2, given that x1 equals to x1, and finally multiple P x1 equals to x1. And for this part, we can use the Bayes rule, and it is equals to P x for specific situation is the I is equals to 1, and there we use I to represent the common circumstance, and it is equals to P xi equals to small xi. It equals to the sum sigma k equals to negative infinite to infinite P xi equals to xi, and given that xj equals to k, and and then multiple p xj equals to k, and we can find that this part, it is a joint probability, and it is equals to k equals to negative infinity to infinity, p xi equals to xi, xj equals to k. And also we can write the p xi equals to xi, and given that because the properties of the Markov chain, we can given that we can use in this property, and given that xi minus 1 equals to xi minus 1, and this is equals to the joint probability xi equals to xi minus 1 equals to xi minus 1, divided by the probability of p xi minus 1 and equals to xi minus 1. And using the conclusions above, we can find that the Markov chain is statistically determined by its second order probability masses, which is p xi equals to xi, xj equals to xj for any ij equals to 1, 2, and until n. So this is the non-question.